This video will look at the empirical rule and gives us an introduction to the normal distribution. The empirical rule states that if a distribution is normally distributed, then within one standard deviation of the mean in either direction, there will be approximately 68% of the data values. Within two standard deviations of the mean in either direction, there will be approximately 95% of the data values. And within three standard deviations from the mean in either direction, there will be approximately 99.7% of the data values. We'll look at a picture of this in just a few minutes, but just know that we can apply the empirical rule if a distribution is normally distributed. A distribution is approximately normal if it is symmetric or bell-shaped. So if you read a question and it says that the distribution is approximately normal, or if it says that it is symmetric, or if it says that it's bell-shaped, then we know that we can apply the empirical rule. And we know that it is symmetric or bell-shaped or normal if the mean divides the distribution in half. Remember that the mean is like the balancing point of a distribution. So if the balancing point is the middle value, then we know that it is symmetric. Here is a picture of the empirical rule, or the normal distribution. As we talked about above, from the mean to one standard deviation above and one standard deviation below, we have 68% of the data values. Since this is symmetric, we know that we would have 34% in each of the two regions. Again, from the statement above, we know that 95% of the data values are within two standard deviations of the mean. Well, 34 and 34 make 68, so on each side we need another 27%. So that would be 13.5% in each little region. And there are all kinds of great pictures on the internet that you can refer to as well. And lastly, within three standard deviations of the mean in either direction, we have 99.7% of our data values. So in each of these little regions here, we have 2.35%. And again, we have much better pictures on the internet if we're looking for them. Here's another example. Right. Now we are going to look at the example here. It says the scores on a college entrance exam have an approximate normal distribution. Here is our keywords. Once we know that it is approximately normal, we know that we can apply the empirical rule. And we know that if we can apply the empirical rule, then we are looking at the normal distribution, bell-shaped curve, where we have the mean drawn and the different percentages that we just talked about, where we have a mean of 52 points and a standard deviation of 11 points. According to the empirical rule, approximately what percent of applicants' scores would be, and then they give us a whole bunch of these. Well, let's first build our picture that we can use for all of these questions. So I have here a picture with the empirical rule. Again, it said that the mean was 52 and the standard deviation was 11. Since the mean is 52, we can draw in the mean being 52, and we can add one standard deviation to give us 63, and we can subtract one standard deviation, giving us a value of 41. From here, we can take the mean and add two standard deviations to it, or add another 11 to 63, giving us 74, and we can subtract two standard deviations from the mean. 41 minus 11 is 30. And lastly, we can add three standard deviations to the mean, giving us a score of 85. And we can subtract three standard deviations from the mean, giving us a score of 19. So we can use this picture and these values for all of the questions in this example. Here's a nice clean picture. We want to find the percentage of values that are between 41 and 63. So since I'm looking for the values between 41 and 63, I'm looking for all of the values that are in this region. And according to our picture before, 68% of the data values are in this region, are within 1 standard deviation of the mean. Part B says between 30 and 74. Well, between 30 and 74 is 2 standard deviations from the mean. And we know, if we look at the picture that we have before, we know that 95% of the data values are in this region. Part C asks us to find the percentage of data values that are between 19 and 85. Well, between 19 and 85 is 3 standard deviations in either direction from the mean. We know from the empirical rule that that is 99.7% of the data values. Part D asked us to find the percentage of data values that are more than 63. And this is where it gets a little bit complicated. More than 63 means all the values to the right of 63. This would include everything that is in this 13.5% region, everything that is in this 2.35% region, and everything that is in this 0.15% region. Now, if we were to add all of these up, we would see that this is 16% of the data values. Another way that we could look at this, though, is we could think of this as what is left over. So I'll explain what I mean here. Since this distribution is symmetric, since it is approximately normal, we know that approximately 50% of the data values are to the right and approximately 50% of the data values are to the left. We know that 34% of the data values are within 1 standard deviation of the mean. 68% in both directions, so 34% in one direction. To find the red shaded area, we can just do 50 minus 34 to get 16%. I'll do that in red so it matches. 16%. So a few different ways of finding the answer for part D. And lastly, it asks for the percentage of data values that are less than 52. Oh, I kind of just gave that one away with the previous example. It would be 50%. Because again, this is a symmetric distribution. 50% of the data values are to the left of the mean, and 50% of the data values are to the right of the mean. So that is how we use the empirical rule to find the percentage of data values within different regions of the normal distribution.